And then just follow along. Now, this one right here, I will accept either of them for the full mark. You can either leave it as, oh, no, I'm a liar. I'm the worst kind of liar. If you wrote it that way, it's half a mark. If you wrote it that way, in blue, it's a full mark, but you also could have written it this way. X plus 4, X plus 4. I would have accepted anything in blue or green for full marks. The yellow was a half mark because you can further factor that. Same thing in number 8. Half a mark for that. Full mark for that. I'm not going to use that green anymore. None of the highlighters work with it. Especially if I used green. It's like when you wear a green shirt in front of a green screen. It doesn't work. Super funny when you do it, though. Your head floats. If any of you are in broadcasting, it's a fun thing to do. And then 10, same thing. If you only went to where the pink was, you get a half mark. If you finish it off to green, you get the full mark. Any questions up to number 11? Now remember, ladies and gentlemen, factoring is practice. There is no magic formula. You don't wake up one morning like, I know how to factor. You have to practice. And the more you practice, just like everything in the world, the better off you get. Aaron. So you're asking me, could you write this? X minus 6 and X plus 5. Of course you could. But it would matter if you wrote this. X minus 5, X plus 6. That, totally wrong. Everybody understands that, right? Factoring is the reverse of expansion. So if you do the work and then you go back and you expand it and you don't get this, you've done it wrong. Yeah? Okay. 12, 13, 14. Remember, if you stopped at the yellow, it's a half mark. If you got to the green, it's a full mark. Stopped at the yellow, it's a half mark. Got to the green, it's a full mark. Now, down at the bottom here, we're going to get a little funky. You get a full mark if you went there. I will give the full mark, but I will give a bonus mark if you remembered to take the 2 out at the beginning there. So that one doesn't go to a half mark. That goes to a bonus mark. Yes. How far? Well, no. It's all been recorded, so you can always check it later. Now, everybody understands what I mean about 17, right? Right? Like, all of you, I showed you 16 and 17 specifically yesterday because the brackets make that a single thing, right? So there's a common factor. So it goes to the front, and then we're left with what's left over. Same thing here. You see 6x and 4 would go to the front, but then, of course, 6 divides by 2 and 4 divides by 2. So you bring a 2 out to the front, and you're left with 3x plus 2. Yeah? Yes, because that gold doesn't work very well with the highlighter. So the green gets you the full mark. This is a plus 1. So you can actually get 19 out of 18 on this page. And of course, this one, everybody remembers this trick, yes? Can anybody explain to me why this trick works? I explained it to you quite heavily. So all of you recognize that those are almost exactly the same thing, right? But this is a positive x and a negative 1, right?
Oh.
Whereas this one is a positive 1 and a negative x, right? Now, we all know that every single number in the universe has 1 as a factor, right? But it also has negative 1 as a factor, right? Because if I choose, for example, 24, we all know that 1 times 24 is 24, right? But so is negative 1 times negative 24, right? So since... Yeah, I'll just leave it. Since negative 1 is a factor of every single number, it's a common factor of every single number, isn't it? So I can divide this by negative 1, because negative 1 is a common factor of both 1 and x. 1 divided by negative 1 becomes what? Negative 1. And negative x divided by negative 1 becomes what? Positive x. And then our common factor moves to the front, right? Just like if we did 3x plus 9, we would divide that by 3. The 3 would move to the front. I'd have x plus 3, right? So this negative 1 moves to the front, but what's already there? A positive x. So just like when we move something out of a radical, we multiply what comes out. So what's negative 1 times positive x? Negative x. And then here I already had x minus 1 and a 3. So now x minus 1 and x minus 1 are the common factor, right? So I get x minus 1, and then if I divide them both by the common factor, cancel, cancel, 3, cancel, cancel, minus x. Does everybody understand? If you ever have the same terms with different signs, you can use this move to make them exactly the same. The only trick is you got to remember that this is going to change. So what if this was negative x? What would I be writing right here now? Positive x, because I would have brought out a negative 1. Negative 1 times negative x would be positive x. Is everybody good? That is really tricky factoring, right? Like that stuff you really got to know what's going on. Now I've shown you, I gave you a couple like that without telling you what to do to see if anybody would figure it out. And now you've seen the trick, right? So we are all good? Yeah, yeah? All right, your next page, page 70, should look like this. Right? Okay. Now, I want to do the first one with you, and then I want you to do the rest. Okay? So here we go. Right now, we do not know this number, yes? I want it to be an integer. Who remembers what an integer is? Positive or negative number with no fractions or decimals, okay? So a lot of kids get fooled here because they see this plus and they say, well, this has to be a positive number. It doesn't, okay? 7 minus 3 doesn't exist. That is 7 plus negative 3. But math people are lazy, so they've made that symbol. Everybody cool? So this here can be a positive or a negative number. Everybody good? Now, whatever this number is, if I wanted to factor this trinomial, I would need numbers that multiplied to that blank, yes? Right? And they would have to add to what number right now? What number's in front of R? 1. So I need numbers that will multiply and add to 1, yes? So if they're going to add to 1, how far apart must they be? How do I make two numbers equal 1 when I put them together?
Positive number and the negative number is 1 less than it.
I need a positive number and a negative number, don't I? Okay. So I need, for example, positive 2 and negative 1 would get me 1, wouldn't it? Okay, then what number would go here if I use that? Positive 2? Negative 2. 2 times negative 1 is negative 2. Everybody with me? Everybody with me? Okay, give me another number that could go there. So, no. Positive 6, negative 5 isn't the number that would go there. What's the number that would go there? What kind of 30? Negative 30. Now, why? Now, because it is positive 6 and negative 5. Does everybody follow me? Everybody? Good. Do 2 more. By yourself, do not say it out loud. Tell me 2 more numbers I could put there. Easy peasy, right? Somebody give me one of their numbers. No, you've already done 2. Minus 20. Why negative 20? 4 and 5. Give me another one. There's 30 of you. Somebody other than Gurveer and Ali knows these answers. I mean, Abby. Abby. Sorry, Abby. No, you don't. You're like, Mr. Myers, come on. I know, I can tell. I can hear it in your voice. You think you think I'm not tuned into these things, but I am. I know. Backwards and forwards. Except your name, apparently. Ibba. Huh? See what I did there? Abby backwards would be Ibba. I said I figured you backwards and forwards. What? Give me another number.
Okay, negative 90.
Negative 90. Why?
10 minus 9.
10 and 9. Excellent. Somebody give me another one. Ezra. 42. Why? Excellent. Give me another one. See, I like how nobody else is putting up their hands, even though they've now had 6 examples, because they're trying to think of what the problem is. Javon. Why? 8 and 7. Good. No, you've already done yours. I'm waiting for somebody else. You know what? Come up with 3, because you'll notice 2 and 3 are exactly the same. Come up with 3 for each. If you don't want to say them out loud, I'm going to make you write down 6 more. Go. And they can't be 22, 30, or 56, or 42. Can't be any of those. What else did I miss? Oh, can't be 90. Nino had 90. Can't be any of those ones. So I want 6 more. So what's the rule? How do you figure out the 6 numbers I want for 2 and 3? What is the only thing you have to do? Go ahead, Gurveer. I'm not mad at you. You understand that, right? I'm exasperated with everyone else.
You get a number, and you get a number of 1 less than it, and you can make it a negative.
Any number, the number that is 1 less than it, you make negative. Paige, what is it? Nice. So this would be negative 110, because 11 and 10. First try. Give me another one. No, you already did one, Javon. Edward, give me one. We already did 3 and 2. Oh, no, right there. No, we didn't do 3 and 2. 3 and 2 works. Negative 6, because positive 3 minus 2. Give me another one. You already did one. I like how you're putting your hand behind Paige like you'll fool me. Paige, yeah, exactly.
Negative 72.
Negative 72. Because 8 and 9. Carlo. Negative 12. 3 and 4. Give me another one. Since a 2 can't work. All right, I've had enough of this. Whatever. What's different in 4? Yes, look closely at 4. What is different?
The negative.
The negative, which means which one gets the negative? In 1, 2, and 3, if I had 10 and 11, which gets the negative? The 10, the smaller one, right? Because 11 minus 10 is 1. So what gets it here?
The 11.
The 11. It would be 10 minus 11, right? To get a negative 1. Everybody with me? Would all these numbers work in 4? Yes, except the negative would be switched, right? Does everybody understand? Now, some of you are saying to yourself, self, what? Why is he saying this? Because this is why you can't do that switchy thing. Remember when Aaron was asking if I could have b plus 5 and b minus 6, if I was allowed to have b minus 6 and b plus 5, and that was okay, but we couldn't reverse the signs? This is why. Because if you reverse the signs, you end up with a different term in the middle. Okay? You have to get the signs right to get the middle term right. Now that middle term has a name, but you don't need to know what it is till next year. We'll just call it the middle term. Okay? Everybody cool? All right, what's different in 5? Nino?
The number next to the 11.
The middle term is now a 2. Well, when it was a 1, our factors had to be 1 apart. So how far do they have to be apart now? 2 apart. So give me a number. 9 and 11. So this could be 99, couldn't it? 9 and 11. Which gets the negative? The 11, because 9 minus 11 to get to negative 2, right? Give me another one. Javon. 24, which would be 6 and 4. Which gets the negative? 6. Nice. Give me another one. Carlo, hit me. 8. 4 and 2. Which gets the negative? 4. Everybody cool? Ease, peas, lemon squeezy, right? What's different in 6?
There's the blank is in front of the
The blank's over there, right? Under there.
Underwear.
Oh! So now we're restricted, aren't we? When this was the blank, we had how many options? Starts with an I, ends with an E.
Infinite.
Infinite options, because as long as the number had factors that were 1 apart from each other, we could do it, right? Do we have infinite options now?
No. Does it have to be 6 apart, right?
No.
No. They have to multiply.
They have to multiply to 6.
Oh.
So they could be 1 and 6, couldn't they? If it's 1 and 6, what's this number going to be? 7. What if it is, what's the other one it could be? 2 and 3. So what would this be? 5. Are there any other options? Not if that's a positive.
Negative 2 times negative.
Could it be negative 1 and negative 6? Then what would this be?
Negative 7.
Negative 7. Could it be negative 2 and negative 3? So then what would this be?
Minus 5.
Minus 5. Great. You do it for 7. Negative 1 times negative 6 would give us this positive 6, right? But then when we added them together, we would get negative 7. Okay? So what are my options for 7? What are the easy 2 options? I'd have 2 and 5, which would make this. Or 1 and 10, which would make this. And what else could it be? Negative 2 and negative 5 to get negative 7. Negative 1 and negative 10 to get negative 11. Yeah? Everybody good? All right. Now, 8 is very tricky. Why? It's got a 4 out front, a coefficient, right?
What?
That 4 changes things, doesn't it?
Why? Oh.
I don't know. Can you? I have to check. Mr. Aaron Stevens. I know it isn't, but you sit right by Ryan, and I always mix them up. And the guy I know that's named Aaron, his last name starts with S too, so it's a giant pain in the rump. But yes, you can. Yes, I know it's Aaron.
Oh, I figured, but you've been saying it like you
Because he said it on the first day. He made the joke
because you never actually.
that your name was Aaron, Aaron. So that's why I call him Aaron.
We called him AA wrong for a whole
If it bothered him, I would stop. But since he made the joke, I feel that he's okay with it.
Yeah.
Everybody does that to me. Like, Mr. Myers, why do you keep doing that to that kid? That kid hasn't asked me to stop. Right? All they would have to do is ask. Because I do that, and then they laugh. And then that seems to me that they're okay with it.
I think I might start going to my EBA.
Right? I don't get it. Anyways, where was I? Right. What could go there? So why is this difficult? What is special about 4 and 9?
If you multiply to those two numbers, right?
The 5 goes in the middle.
Great, it's a common factor. 4 and 9 don't share a common factor, except 1. Something special about the number 4 and the number 9.
They go to perfect square.
They're perfect squares, aren't they? Now, you know when you factor this, you're going to end up with blankety blank and blankety blank, right? So, could you go 2x, 2x, and 3y, and 3y?
Most definitely.
Could you? Is 2x times 2x 4x squared? Is 3y times 3y 3y squared? Or 9y squared, I mean? So could this be positive? And this would be positive, right? Which would mean, what would my number in the middle be? 6?
5, 4, 7,
Holy crap. First, 4x. Outside, 6xy. Inside, 6 more xy. How many? 12 is one number that could go there, right?
9.
Because if we use 2 and 2 to make 4 and 3 and 3 to make 9, when I expand that, I get 6xy plus another 6xy, which is 12 xy's. Okay. Are there any other options?
6x plus squared.
No, just 6xy because you're adding. Are there any other options? There are, but I have not taught you how to find them yet. Which is why it's the last thing we're doing. See how I did that? All of you could figure this one out because it's a lot like a difference of squares, isn't it? Right? Everybody's cool with it being 12, but the other options, unless you've already done factoring before, you don't know how to find them. Okay? Everybody understand? All right. So let's look at this next one. If that's the area of the rectangle. So there's a rectangle, right? Its area is x squared plus 7x plus 12. Agreed? How can you tell me how long each side is? What would you have to do to the area?
You would have to factor it because then the numbers in the brackets would be the perimeter numbers.
Absolutely correct. Just like if I gave you this. What's the area of that rectangle?
6.
6. What are the sides? What are the factors?
2.
3 and 2. The factors live on the edge of the rectangle. So, what are the dimensions of this rectangle?
7 and 12. Right?
What do you need to do with that?
Cut it in half.
No. You need to factor it. How do you factor that?
You can't, can you?
Oh,
Of course you can.
add to 7 and multiply.
You need to add to 7 and multiply to 12. We've done that like 80,000 times. Jazz.
I'm sorry.
X plus 3 and x plus 4. I'm not trying to sound exasperated, Nino, but my problem is how something like this, it's not that you don't know how to do it, and I'm not picking on you specifically. It's that some of you are acting like it's something totally new, like you've never seen before. And the only difference is I took away, you don't usually give you those instructions. If I gave you that and said factor it, you would all do it. And 2 days ago, did we not work with our algebra tiles and talk about how the factors live on the outside and the rectangle is the product? Okay. So it was 3 school days ago. I apologize. Punks. How are you going to figure this out? I want the area of the shaded region. I will help you by shading it more specifically. How are you going to tell me how much of this rectangle has been shaded in pink? What would you do? What would you do? The question is to calculate the area of the shaded region.
You multiply 3x plus 5 and 5x minus 4.
Why would you multiply those? What would that give you?
Because that's the printer and length.
That's the length times width of everything pink now, yes? Yeah. But it's not all pink, is it?
No, but then you take away the middle factor.
You would take away this. So you would do the green length times width, and then what?
Take away.
You would subtract the purple length times width,
Why is
right?
there a little purple on the outside?
Oh, because that just didn't have room. I didn't have room to write it in there. Right? And that seems pretty easy, yeah? But a bunch of you wouldn't show your work, and a bunch of you are going to get this wrong if I say just go and try it. So guess what?
Wait, can we?
Go and try it. That's what I was about to do.
Okay, yeah, I want
Try it. Because I'm betting, I am going to bet that 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 of you, I'm going to bet 9 of you get this question wrong.
Get it wrong?
Get it wrong. Even though you know it, everybody agrees this is what to do, right? You have the whole pink rectangle and you're cutting out the middle, yes?
Yeah.
And cutting out is minus, yes? Okay, go. And by the way, this is not any sort of, what's the word I'm looking for? This is not any sort of statement on your math skills or anything, because you're all going to do the right math, but you're going to make a very small but significant error. Aaron. When I do. Thanks for keeping me in line. Does everyone agree with my first step? You've all had time to write the first step down. Are you happy? Nobody's made a mistake yet, have they? Excellent. Let us carry on then, cabbages. No.
I always ask him.
Because I do my work on here or in pencil. So I can erase it.
I'm at a loss.
Are you at a loss?
I'm just confused.
Does that make you one of my 9?
No, I just don't remember, or I don't know what to do because of one number. If that one number wasn't there, I'd be fine. I don't know what to do with all of them. Like, yeah. I got the first part, though. I just don't know what to do with all this.
Now, so everybody knows they're going to multiply those 2 binomials together that I wrote in green, right? Those first 2 binomials that I wrote in green, you're going to multiply them together, yes? Now, everybody multiplies their own way, right? Some people like to imagine the algebra tiles. Some people write it all in a wide, long, straight line sideways, then collect their like terms by drawing circles and squares and rectangles. And some people stack them the way I showed you, right? But whatever you did, who would like to tell me what they think is the answer to the green side times the other green side? Jazz? 15x squared. 15x squared plus 13x, I know, minus 20. That's what Jazz says it is. Whether you agree or not, we're cool. All right, that's what he says. Would anybody like to volunteer the purple ones? Edward. Negative 2x squared minus. I just didn't hear you. What's your next one? 2x minus 12. Okay, I'm going to turn this on. And there is one of the mistakes. Because this multiplies to this, right? And what's 4 plus 6? 10. Now, I know what you were trying to do, Edward, and I'm going to show you in a moment. I'm going to show everybody in a moment. Plus 10x, and 0 plus 12 is plus 12, yes? Now, if everybody got to there, you're in good shape. Here's where some of you are going to make your mistake. That symbol right there is minus, yes? This is all one rectangle. So that negative has to go there, there, and there. So what I actually get is 15x squared minus 2x squared, which is what? 13x squared. And 13x minus 10x, which is what?
Yeah.
Positive 3x. And negative 20 minus 12. Negative 32. And I am betting there are at least 9 people in the room that here have negative 8. Be honest. There's 2 nods. Only 2 of you? 3. Okay. Or you did something funky over here with this negative like Edward did.
Oh my god. I thought that was a 7. Mr. Myers, it's your writing, that's why.
That is obviously a 2.
It looks like a 7 with a line through it.
No, this is a 7. The line through the 7 does not come through the bottom of the 7. Oh, okay. Oh, gee. That is not a 7. That's a 7. All right. All right. Are we all good? All right. It's 1:40. We got loads of time. Now listen. Listen to me carefully. You need to be very good at factoring that to carry on. Can all of you factor these? I know you can't factor them maybe as fast as your neighbor or as fast as I can, but you need to be honest with yourself right now. If you can't factor that effectively every time, you're going to have a lot of trouble with what we're about to do. Okay? So obviously you don't have to broadcast it, but you need to know that if you can't do that, then you need to be making very sure that you spend the next 20 minutes to half an hour actually paying attention to what I am doing. And by actually paying attention, I mean you're not just zoning out for 10 seconds, then looking up, oh crap, I didn't write that down, and frantically writing down what I wrote without thinking about it. Can you all factor that? You don't need to say it out loud, just in your own head. Can you factor that? Yes or no? That's what you need to know. And if the answer is yes, you need to be able to factor all of its different permutations. So if I gave you this, x squared plus 8x minus 20, you would be able to factor that. If I gave you x squared plus 8x plus, x squared plus 12x plus 20, and x squared minus 12x plus 20. You would need to be able to factor all of those without making any sort of incrimination about yourself. Can you handle these? Okay, and the answers are, of course, x plus 10, oops, wrong one, x minus 10, x plus 2, x plus 10, x minus 2, not 20, x plus 10, x plus 2, and x minus 10, and x minus 2. All of you can do that, yes? Okay, please turn your pages to page 71. The font, Budmo Jiggler. That's the name of that font. I didn't name it. It's called Budmo Jiggler. I don't know why. It sounds dirty. Now, we are going to now do, it's not any more difficult, but it is slightly more complex. All right? So, if I gave you that, is that factored or expanded? That is factored, which means we would expand it, yes? And if we were going to expand that, we would do x squared plus 4x plus 6x plus 24, and we would get x squared plus 10x plus 24, right? And by the same token, if none of this were there, and I only gave you that, that's a product, and we would factor it going backwards by needing numbers that multiplied to 10, multiplied to 24, and added to 10, yes? Then we would go backwards, and we would get to here. Everyone's cool, right? Wax on, wax off. We're all good, yes? Okay. Is this factored or expanded? Factored, which means we would expand it, yes? And to expand that, we would go 2 times 3 and get 6x squared, yes? And then we would do 2x times negative 2 to get negative 4x, yes? And then we would do 1 times 3x to get positive 3x, yes? And we would get 1 times negative 2 to get negative 2, which would give us 6x squared, minus x minus 2. Is everybody cool? Now, please notice this one in pink is different than the one in purple, right? Because the one in purple has no first coefficient. So all we need to do is multiply to 24 and add to 10, right? Everyone agrees? But in this one, I do have a first coefficient. So this move isn't going to work because this move has nothing to do there. Everybody with me? So we need to devise a way that will get us from this back to here. Now, the easiest way to do that is the way most of you approach math, guessing and checking, right? Like, let's be honest. Most of the time, if I give you a math question, you guess, right? Like, not every time, Ryan, and not every kid. But guessing and checking, it's relevant, isn't it? It's okay to guess and check, right? So you will notice, of course, that when I multiply this out, the first thing I have to do is the first two terms, right? And those two terms give me that, didn't they? So the first guess you would make is you would need factors of that. So I'm going to label these as A, B, and C. So if we were doing a guessing and checking method, our first guess, and we're gonna do a lot of methods here. So we're gonna have method 1, and we're gonna call it guess and check. In guess and check, I need 2 factors of A. So in this case, I need 2 factors of 6. So what are my options? We already know it's going to be 2 and 3 in the right answer, yes? But if we didn't know the right answer, what are my choices here? 1 and 6 or 2 and 3, right? Has to be. Everybody agrees? Okay. And then, you're smart kids, you know that this last number gives me this number, doesn't it? So I must then need 2 factors of C. And in this case, what are they? 1 and 2. Their only option is 1 and 2, yes? So if the numbers are small, guessing and checking is great. Why wouldn't you try it? Because there's only 2 choices for 6 and only 1 choice for 2. So it doesn't take any extra time to guess, does it? So you might say, and don't write this down, just this is how you would do it. You might say 6 and 1 and 2 and 1. This is the way, I was not taught this. I had never seen this until later in life. But this is the way people seem to be getting taught this now. Like when I get a student teacher and I show one of my other methods, they're like, wow, that's awesome. I've never seen that before. They want to do this guessing move. Okay? So you write them out, and then you have to go crossways. You do 6 times 6, which gets you 6, and 2 times 1, which gets you 2. Are 6 and 2 1? No, right? So it can't be that one. Okay. Oh, and remember, this is negative, so one of these has to be negative, right? Doesn't matter which one, let's make it that one. So we tried 6 and 1, so let's try 3 and 2. Cross, what's 3 times negative 1? Negative 3. What's 2 times 2? 4. Is negative 3 plus 4 negative 1? Negative 3 plus 4 is negative 1? It's positive 1, so it can't be that. Okay. What if I change it to 2 and 3? What's 2 times 1? Negative 2. What's 3 times 2? Does that get me negative 1? Doesn't work again. Darn it. Okay. What about 3 and 2 and negative 2 and positive 1? What's 3 times 1? What's 2 times negative 2? Does that get me negative 1? Yes. So I have 3 and negative 2. Right there. 3x minus 2 and 2 and positive 1. 2x plus 1. If you don't see how it works, it's okay, because I really don't like that method. And here's why. What if I gave you this? What if I gave you 12x squared, don't write this down, plus 32, no, 32 is a bad one, 42, and 13x. If you were to guess and check this, you would need factors of 12, right? What are your choices? 1 and 12, or 2 and 6, or 3 and 4. And sometimes you may have to flip them, right? What are your choices for 42? 1 and 42, 2 and 21, 3 and 14, 6 and 7. And sometimes you have to flip them. Do you see how much work you would have to do? Does everybody understand? You'll get the answer eventually, but you're guessing. Personally, I would rather know how to have it right away, the right answer. But that's just me. So let's talk about that. Here we are back here. This is what we're working with, yes? ABC still, right? Right? Now, I know of 2 other ways to do this. I actually know of 4 other ways to do this, but 2 of them kids hate. Every kid hates them. I don't even use them. If you don't understand one of the 2 methods I'm about to show you, then come and see me and I'll show you one of the other methods. Everybody cool? All right, so the first method is this. This is method 2. I don't have a name for it. I don't know what it's called, but we're going to do. It starts, first thing we do. Now, if this was 1, we do 24 and 10, right? Yeah, go. Right? If that's a 1, we do 24 and 10. Yeah? Well, this is now how many times bigger than 1? 6 times bigger, right? So that must mean we don't want to multiply to 2. We need to multiply to what? When it was 1, we multiplied to 24. This has gotten, what do we have to multiply to? Negative 12. Why? Because 6 times negative 2 is negative 12. The polynomial is 6 times bigger. Is everybody cool? So the first thing we do is A times C. That's the first step. And then our second step, we use A times C for the multiply, but we keep B for adding. Everybody cool? Everybody cool? So what is 6 times negative 2 is negative 12, right? So that means I need to multiply to negative 12, but add to what? What's B here? What's B? Not 1. Negative 1, right? What are the factors of 12 that give me negative 1? Negative 1 and 12 gets me negative 1 when I add them. Is it 1 and 12? It's 3 and 4, right? Which gets the negative? Negative 4 plus 3 would be negative 1, right? So our third thing is 6x, because we're dealing with 6 this time, plus 3, and 6x minus 4. Is everybody cool? Now, please look carefully. 6 and 3. If this was the very first lesson of factoring, what would you do with that 6 and that 3? You'd GCF it, wouldn't you? What is the GCF of 6 and 3, Ryan? 3. So you would divide this by 3, wouldn't you? And what is this one? You divide that by 2, wouldn't you? What is 6x divided by 3? 2x plus 1, right? What is 6x divided by 2? 3x minus 2. And look at your answer. Do you have it? Everybody cool? It takes what you already know, so you didn't have to learn anything new, but it gives you the answer. Is everybody good? Now, in my mind, I like this method the best, personally. I know there's 3 other methods, but this is what I like the best. So what I like to do now is I like to do a couple of these using this method. And if everybody's okay with guessing and checking or this, then I ask you to carry on. If you're not, I'll show one of the other methods. Is that cool with you guys? Does that sound like a decent attack? We've got 2. But one of these 2 works for you every time, are you cool? Okay, so let's try this very first one here. I'm going to label them A, B, C, just to help. Right, Ezra? Very good point. Thank you for asking that. I usually address that, and I forgot to this time. This 6 bothers us, yes? At some point when you make factors, you have to do division, right? Did we do any division down to 3? No. We had to divide out. The only reason we knew that it was 12 was because we multiplied this 6 here, right? So we have to get rid of that 6. 2 times 3 is? That's the 6 that we carried through. We're getting rid of it. Everybody cool? There's a way longer explanation for that too if you really wanted to see it, but I don't want to get into that if people are happy. So let's look at this one. Would guess and check be good here?
No.
Why not? Yeah, 20 could be 1 and 20, 2 and 10, 4 and 5, right? 3 choices. And they could flip. It could be 1 and 20 or 20 and 1, right? And 10, 1 and 10 or 2 and 5. And it could be 1 and 10 or 10 and 1, 2 and 5 or 5 and 2, right? Pain in the butt. So maybe we don't want to do it there, right? So let's go with method 2. So the first thing we do is we multiply 20 times 10. What's that? So I got to multiply to 200 and add to what? 33. Well, we know it's not going to be 1 and 200, and we know it's not going to be 2 and 100, and we know it's not going to be 4 and 50, right? Because they're not close enough. As we get a little higher, keep going through the pairs. 8 and 25. I'm helping us out. You'd all get there eventually. Does 8 and 25 make 33? So we know it's 8 and 25, right? So it's going to be 20b squared plus 8 and 25, right? Does it matter which one I put first, do you think? 8, right? And then 20b squared plus 25. Now, what are you going to do with that? What's coming out of there? What's coming out of 20 and 8?
4.
4. To get me 5b squared plus 2, right? Not 5b squared, sorry, just 5b, dummy head.
Wait, where's the 2 then?
Oh, because we don't, you'll see in a sec. Okay? Everybody cool? Right? Okay. And what's coming out of here? 5 to get what? 4b plus 5. Is everybody good? Now, check. Because you can always check in this unit, can't you? What's 5 times 4?
20.
What's b times b?
B squared.
B squared. Is it right? Okay. What's 2 times 5? I needed 10, right? What's 5 times 5? 25. What's 2 times 4? Is 25 and 8, 33. So we did it right. Now, Paige and Nino all asked, why did the original 2 I wrote there was an accident. I didn't mean to, right? Because, of course, I remember that we are trying to factor this, aren't we? And we know at the end, those b's have to multiply to make a b squared. So I never should have written the squared there. It should have just been 20b. Just like I did up here.
Forget about the squares.
You forget about the squared when you get to this step. Because when you expand it out later, that square is going to come back.
Oh, that's
Cool?
yeah.
And with the
Are we allowed to
b's
just-
here.
Are we allowed to just write it how you wrote it at the bottom and it's fine?
Yeah, this is the answer. This is done.
Never mind, I see it. B.
5b and 4b. Because 5 times 4 is 20, and b times b gets me the b squared. Now, do you want to do a guess one on here?
No, please.
No.
I don't like the guessing, personally. Right? I don't like it. But let me warn you of this. You don't want to do guessing when the numbers are big, right? But sooner or later, you'll do enough practice that you will be able to guess because you're going to know it's not 1 and 200 or 2 and 100. You know it's going to be something in the middle. Picking up what I'm putting down? Usually, it's weird. I do more guessing now than I did when I was a kid. Because I've practiced it so much, I'm starting to see the patterns and I can guess better. Like I can make a better guess than just, is it 12 and 1, 12 and 1, 2 and 6, or 3 and 4? I know, that one's probably going to be 3 and 4. You picking up what I'm putting down? And after you practice more and more, you may actually start using the guess. So let's look at this one then. We won't use guess. Everyone's cool? All right. So what do we need to multiply to now? What do I got to do? I need to multiply to what kind of 30? You said 30. Negative 30, right? Because that's negative. And what do I need to add to? Negative 13. What is it? It's 15 and 2, isn't it? You want to say 10 and 3.
No, I was just making a speed.
Yeah. It's 15 and 2, right? So 3s, is it plus 15 or minus 15? Minus 15 and 3s plus 2. Now check. Is there a GCF there?
3.
What is it? 3. So I got to get rid of that 3, which leaves me with s minus 5. Agreed? Everyone agree? Is there a GCF there? No, so we leave it. 3s plus 2. Mr. Mize, did I do it right? Did I do it right? Did you? What's s times 3s? 3s squared. Did we do it right? What's negative 5 times positive 2? Negative 10. Did we do it right? Yeah, because if the ends are right, the middle's right. Is everybody good? Now, stop for a second. You don't have to write this down. Remember how I said I wanted you to keep this in your head? This guy right here? Remember we talked about it? If we call them both square roots, then only 12 can go there, can't it? But if we do what we just did, I need numbers that multiply to 36, right? And add to what? Anything I want, yeah? So could I use 1 and 36? So what would be there? 37. Could I use 2 and 18? What would be there? 20. Could I use 3 and 12? 15. Could I use 4 and 9? 13. Could I use 6 and 6? 12. And all of those would be factorable. Everybody cool? All right, let's get back to where we were. How are you feeling? This is like I said, it's not hard, but it's complicated, right? There's a lot of little steps to take. Even if you do guess and check, there's still a lot of little things that can go wrong, right? You ready to try 3 by yourself? Try it with your neighbor. Some of you already have. That's cool. Is there anybody that is feeling that neither of these methods is even beginning to work for them and you would like to see another one? Or is everybody okay? It's hard to tell because even when I ask what 7 plus 2 is, nobody puts their hand up. Is everybody okay with one of these two methods? Or do you want to try a couple by yourself to see if you're okay with one of these methods? Okay, you guys try 3 and 4 and we'll see what happens. Pace, you know it's recording, right? Yeah. How far? Just to the methods? Pace, you know it's recording, right?
Yeah, I can write it down now.
Okay. So later on, you're going to look at that screen to write it down, right? But you understand why I'm smacking my head, right? What are you doing? Okay, whatever. Yeah, Paige.
I need somebody to multiply 54 and add to negative 21.
Multiplies to 54.
And add to negative 21.
All right, so is it 1 and 54?
No.
No. Is it 2 and 27?
No.
No. So is it 3 and 18?
Yes.
There you go. Right? Now, you should already be figuring out, hey, we're doing this factoring after we did square roots. What did we do in square roots? We practiced breaking the numbers down, right? That's why we're doing this
I
now.
just didn't want to take the time.
No, I know, I understand. And it is practice, and that's why I don't mind helping out that way. right? As long as you know how to do it. That's why I go through. Is it one in?
The method's really good.
Yeah, I like method 2 too. That's actually that's a very new thing to me. I didn't see it until last year, and I actually find it very useful. I kind of fought against it the first time I saw it because I'd never seen it. It took me a few tries to wrap my head around it, and now I'm okay with it. I have another method I like that works very, very well as well, but yeah. The way I learned to do this, there's some fractions involved, and it just scares kids. Even though it's super easy to do, and it's really easy to explain why it works, the fractions bug them. So I'm trying to get away from it because this seems to work really well.
Dividing it by 3 with negative 3 effects 6.
Well, 6 divided by 3 is, and negative 3 divided by 3 is negative 1. All right. So, zip. I'm just going to do this. I'm not going to even talk my way through it. Everybody's done number 3, right? So I need to multiply to 54, add to negative 21. Since this is positive and this is negative, I know they're both going to be negative, right? Is it 1 and 54? No, that makes 55. Is it 2 and 27? No, that makes 29. Is it 3 and 18? Yes, because that makes 21. So negative 3 and negative 18. So I just write it. 6x. Now, can I put the negative 3 there and the negative 18 there and have it work? Yes. Can I do it this way?
What?
Of course I can, because they're exactly the same, aren't they?
Oh, they're just squished together, right?
So, now I take out my GCF. What's my GCF here?
3.
What's my GCF here?
3. No,
6,
Sorry,
right?
I'm thinking.
So this becomes 2x minus 1, yes? Right? And what's this become? X minus 3, right? Now, wait a minute. Wait a minute. If you've just been following steps, you're to here, and you would say, Miss Miles, did I do it right? Did I do it right? And what would I say? Check it, kid. And you would go 2 times x is 2x squared. I need 6x squared. And then, hopefully, you would do this. Wait a minute. 6, 21, 9. Can't I do something with 6, 21, and 9? Something that Mr. Myers said to do every single chance you get? How many of you jumped right into the new thing without doing the thing you're supposed to do first? Be honest. You did too. Everybody cool? Now, watch. So there's my answer, yes? Right? That gets me 2x squared minus 7x plus 3, correct? Multiply that by 3, 6. 6 times 3 times 7, 21. 3 times 3 is 9. So again, I warn you, is it okay to only know steps? No, you got to know what's actually happening, and you have to remember to divide that all by 3. Then you would do it, and that 3 has to stay there. Everybody cool? That was a dinky move to make that one your first try on your own, but you guys were all getting a little cocky, and I wanted to, knock you down a peg. Are we all okay? We're not mad. You're not mad at me. You're like, it's okay, Myers. We see what you were doing. Some of you are probably a little bit mad, but you're okay now, right? You've got some distance from it. You can work with it. All right, let's try the next one. Can I make the next one any simpler? Is there a GCF there?
No.
No. So can I go straight into my steps? Can I? Yes or no? Yeah, so this one's okay. Let's look at this one. Is there a GCF there? 24, 20, and 24. There is. So that one I got a GCF, right? What about this one? Nope. So I can get right into it. What about this one? Get right into it. What about this one? Get right into it. Are you picking up what I'm putting down? All right. Now, Try number 4 all by yourself, and I won't mess with your heads. There are 2 blank pages because there's a lot of weird things that can happen with factoring once you know the basics, and I want space to show you those weird things.
That's freaking me out.
Don't worry about it. It's super easy.
You know, the thing about math is just like every time you think you understand it, it's like, and then there's more.
Well, that's kind of like the world, right?
Yeah.
You know, every time you think you know your way around Abbotsford, you go on a trip to Athens and you're screwed, right? Like
What's Athens?
capital of Greece.
Yeah. Beautiful place. I haven't been there.
It is a beautiful place. Yes,
Wow. You like travel on it?
I do. I don't like the greenhouse gas footprint that it leaves, but
Is it?
I like to travel. Given my choice, if I had unlimited time, I would take sailboats everywhere, like Greta Thunberg. But there aren't that many sailboats. And I don't have that much time. My perfect job would be becoming a tutor on there's about 5 of them in the world, sailing cruise ships. Because then I'd be sailing around, low carbon footprint, but I'd still be teaching. It would be spectacular. All right. So what do I need?
What's the one between 40 and 80? Oh, you're doing it.
What do I need to multiply to? 40, right? And I need to add to negative 18, yeah? Negative 40, right? So is it 1 and 40?
No.
2 and 20?
2 and 20.
Right? Okay. How do 2 and 20 get me negative 18? Is it 20 minus 2 or 2 minus 20?
2 minus 20.
So I get 8p plus 2 and 8p minus 20. What's my common factor in the first one? 2. So I get 4p plus 1, right? What's my common factor in the second one? 4. So oh, come on! That's not on me! What's 8p divided by 4? 2p. And what's 20 divided by 4? Minus 5. Did I do it right? Did I do it right?
Check.
Check it, kid. What's 4 times 2?
8.
8. What's 1 times negative 5?
Let's go. -5.
Negative 5. So did I do it right? Yeah. Everybody cool? All right. What is the first thing I got to do with 5? No. This is one I got to simplify. What's coming out at 24 and 20? 4. So that 4 comes out here. And now I've got 6h squared minus 5h minus 4. Right?
Why did I try that little following back?
Right? And now we do our rules. What do I have to multiply to? Negative 24. What do I have to add to? Is it 1 and 24? 2 and 12? 3 and 8? How do I get 3 and 8 to negative 5? Is it plus 3 minus 8 or minus 8 plus 3? I did. Is it plus 3 minus 8 or minus 3 plus 8?
Oh, that's a good point.
It's the first one. It's plus 3 minus 8, yeah? Javon. Oh, my good gravy. 6. So I got to multiply to 36. Thanks, Javon. Is it 36 and 1? Is it 2 and 18? Is it 3 and 12? Is it 9 and 4?
That. Yeah.
How do 9 and 4 get me to negative 5? What gets the negative?
-9.
Negative 9. So I have. Can I forget about this 4?
No.
Not that 4. And then I get 6h minus 9 and 6h plus 4. What's the common factor there?
3.
3. What's the common factor there? 2. So I get a final answer of 4. 6 divided by 3? 2h minus 3 and 3h plus 2. Did I do it right? 2 times 3 is 6. 3 times 2 is negative 6. 4 in at the end gets me back to 24. Is everybody good? Does everybody feel that one of these two methods is good enough for them? Does anybody want to see, and I won't do it publicly for everybody because I don't want to confuse the issue, but is anybody a little like, maybe that doesn't quite work for me? I'd like to see another version. Is there anybody that is in that boat? Okay, anybody else? No? Okay, your job right now, finish page, on page 72, I want you to stop at 14 because we're going to revisit those other 5 tomorrow. Okay? So you've got 6, 7, 8, 9, 10, 11, 12, 13, 14 to do for homework tonight. Okay? Go diddly-o.